Okay.
You got
So
it.
what were we doing with Pascal's triangle? Why did we do that?
Adding like
Yes.
for pattern finding purposes.
For pattern recognition. Correct. I did not. So what we're going to do first, it's kind of new, guys, sorry. Okay. So a conjecture is an unproven statement based on observations. Okay. So has anyone ever heard the term conjecture before?
Nope.
No. Austin, you have. Where have you heard that before? What?
English.
English. You're right. So, in English, what's a conjecture? That's a conjunction. But close. Yeah. So, a conjecture is basically what we have here. An unproven statement based on observation. How many of you have taken science class? Yeah?
Everyone, you made it.
Everyone. So, what in science is an unproven statement based on observation? Hypothesis. A conjecture is just the math way to say hypothesis, because we already use hypothesis in some class. Okay? So, I'm going to part of why
You can use your finger.
there we go. Part of math is recognizing patterns, and then you make your conjecture based on the pattern that you're observing. So let's look at these here. Okay. What do you guys notice about this? Honest?
They're like circles and they're like fractions.
They're like circles, like fractions. Okay? Like I think you're like right. What else? Awesome.
They're cut in half each time.
They're cut in half each time. So this line is cutting that one in half, right? What else happens? What?
So if it was like a pizza,
Yeah.
I always think of pizzas.
That is smart.
There's twice as many slices.
Okay. So what about the shaded part? What changes with that? What do you notice about that? Yeah.
It gets smaller each time.
It gets smaller. Okay. So are you shading more of the pizza, or are you still shading the same, or are you shading less? Less. Correct. So if you had to put that, let's just say, well, actually, fourth figure. That's a real thing. That is a circle. You're right.
That's one.
What lines do I need to draw? How do I need to cut the pizza? Here. Into eighths. How did you get into eighths?
Because each of them was going up by 2.
Yeah. So a fraction for this would be 1/2, right? You're taking one piece, and you have two pieces altogether. Your numerator is 1, denominator is 2. Here, still taking one piece, but now the pizza's cut into fourths. 1/4. Same thing with 1/6, and then as Pierce just told us, 1/8. Okay? So which pizza should you go for if you're super hungry?
First.
And if you're really not that hungry?
The last one.
Awesome. We're going to try this again. There. Yep. Can everybody see the shading in the stars, or do you want me to make it clear? Make it more clear. This one's shaded, that one's shaded, that one's shaded. And the middle, there, middle, there. Awesome.
The shaded portions are -1 each time.
Okay. What else do you notice? You're right, absolutely
It
right.
goes around counterclockwise.
Yep. So the middle's always shaded, right?
Mhm.
And then which one should be shaded now?
The only on the left bottom corner.
Left bottom corner. Everybody agree? Okay. What do you notice about this one? Morgan, what do you notice about this?
It starts out as one and then it goes to the next.
Okay. So this pyramid has one ball in it. This one has 3. 2 on the bottom. 1, 2, 3. What do you the next one? You got it. Come on. Think about bowling, right? Pretend you're like looking over the pins. What would be the next one? 4 more. Exactly right. That one, that one, that one, that one. Do you have any questions? Okay. I promise I'll get this up. Okay. Now we're describing patterns using numbers, because this is math. So what do you notice between 4 and 8? Goes up 4. Jake. How about between 8 and 12? Goes up 4. Did you say that the first time? I'm sorry. Okay. There we go. So this one goes up 4, that one goes up 4. How about between 12 and 6? 4. How about between 16 and blank? 20. It goes. Why would it go up 20? I don't know.
4.
But you're right, it is 20. What would the next one be?
24.
24. Okay. This next one. Talk about it with a partner. What do you notice? Your partner's the person right next to you.
Which one?
To your left.
How about this?
Oh, sorry. Do this one.
So +2, +6. And then plus 18.
Okay, so we have 2 weeks.
Plus 54.
No, I'd be 81 times.
Okay, raise your hand if you think you know the pattern. Okay, what is it? Multiply by 3 each time. Is that what everybody's thinking?
Yeah.
Okay. 81 times 3.
243.
And that times 3 is 729, correct? Okay, this next one. Somebody give me the pattern. Okay,
It goes up by 2 and then 3 and then 4 and then 2 will go up by 5 and then 6.
okay. So the next 2 numbers should be 16, 22. Exactly right. 1, 4, 9, 16, 25. Jake? Okay. So this one should be, well, it's 11, right? Get 36, 49. What's a different pattern for this one? There's multiple. Jake's exactly right. Clean?
I feel like, numbers squared, so 1 squared is 2.
Well, one
Sorry,
squared.
1 squared is 1, and 2 squared is 4, 3 squared is 9, 4 squared is 6.
Yep, exactly. There's multiple ways to do this. Just like in real life, you can see something completely different than the person next to you. Some of them, though, are pretty concrete, but just kind of depends on.
Just put out just the word thing.
Just hover over the middle screen.
You're good.
You're good.
Okay.
Guys, I'm gonna stop here. Have we taught you guys anything so far?
Yeah. Pattern tree.
I learned what conjecture.
Okay, learn what a conjecture was, but we're not telling you how to find these patterns, are we? We just have to find enough, through observations, figure out what the next two numbers are. Okay? So there's no set rule in stone as to, hey, it's a pattern, it's going to be one of these 3 patterns. No. These are just ideas of what patterns could be. So we get on our homework or we get somewhere else, the pattern might be completely different, but we're hopefully giving you with some tools to figure out maybe what the pattern could be. If you look at the top left one, that's probably the most simplest pattern, meaning it goes up by the same number every single time. Okay? Those other ones, well, we're going up by different numbers. Okay? So it's kind of, we're increasingly, if you will. So just kind of giving you guys tools and some ideas of how patterns can flow. Go ahead.
So, speaking of not going up by the same number every time, how about this one? I'll give you guys a hint. It has to do with something like you did there.
Go, talk to the person next to you. Go. Look at that pattern. Talk. What do you observe? Go.
Split up.
Whatever all you have to do is just like tap the finger. You know, it should make a little dot, you know, but it doesn't matter. I mean, this is up here, or sometimes the picture's over or something. Okay.
It doesn't matter.
Yeah, you got it.
Or you don't put it
No idea.
4.
Teams.
5, 7, 9. Oh, 9. 5.
9, 16. 4, 9, 16, 25, 36. Your perfect square.
What? Oh, 4, 16, and 25.
Yep.
Okay, 4,
1, 9, 6,
25. So that is going to be whatever, 36. So we do plus 36 plus 40. 81, no, 91 and 140. And 140.
You're one of the four.
Perfect square.
Perfect square number.
Perfecto.
Okay. Died down a little bit. So who has the pattern? Jevin, what is the pattern? So you're going up by the perfect squares, right? So what would this be? 91. And 140, right?
So like you explain that.
Yep. So if you... Wow, okay. If you look at the difference between 5 and 1, In math, difference means subtract. That equals 4. So between there is 4. Between 5 and 14, difference, 14 minus 5 equals 9. Someone's running upstairs. So we have 9 between there. Notice here, you have 4, you have 9. Look at the next one. 30 minus 14 is equal to 16. 16. So what you're seeing here is 4 is 2 squared, right? 9 is 3 squared, 16 is 4 squared. So these are your perfect squares. So it's going up by each one of those. The next time, it's going up by the next one. Does that make sense?
Yeah.
So instead of like on the top one, we're increasing by 4 every time. And then let's see, the one that was below, we're going up by 2, then up by 3, then up by 4, then up by 5. Well, this one, we're increasing by the perfect squares.
Okay. This next one. Minute, talk with partner, go.
So it's gonna be
-5.
I don't mind here is plus 8 minus
And
What do you think?
plus 8 and then it's minus would be would be plus 1.
Add those two numbers together really quick.
Right? Plus 1. Plus 1 and then
Those two.
8.
Those two.
What? Did I say that was the next one? Find the pattern.
Raise your hand if you have that.
Nobody?
Nobody.
Jake?
You just click out, if you just, yep, should go away.
Okay. Jay Addison, what do you think the pattern is?
It goes -8, plus 8, plus 8.
Okay.
And then it just, the pattern is like order of the elements, like, then it goes -5. So it gets -2. Then it goes +3, 1. And then -2. -1. And then +1.
Okay. You're completely right. So how do you, if you're looking at these numbers, how do you see that up here on the top row? Here? Yep. What's -5 plus 3? -2. Huh. What's 3 minus 2? Huh. What's -2 plus 1? Interesting. 1 minus 1? 0. How about 0 minus 1 then? -1. And 0 minus 1 again, -1. So you can do it Jake's way, or you can do it that way, either way. There's plenty of ways to do these. Does anybody need that one explained further? Or do you kind of see where it comes from? Thumbs up if you're good to go on, thumbs down if you're not. Okay. Got 1/8, 2/7, 1/2, 4/5. Hunter, what do you think this one is?
5/4 and 6/3.
5/4 and 6/3. Where did you get that? Where did you get that?
Because after 4/5, it's moving up, so it would be 5/4.
Okay. So what are you doing to your numerator between each of these?
The numerator's going up and the denominator's going down.
Going up by what?
1.
Plus 1. Denominator is going down 1. But what about this 1/2?
That was 36.
That's 3/6. 1/2 is just 3/6 reduced, right? It could be 2/4 reduced. But in this pattern, if we see 3/6, then it makes sense.
Do you have any questions on that?
When you take the end off of the total top,
Like that. Thank you.
next one,
Next one.
36181.
Who has a pattern for this one? This one seems like a partner one again.
Let's do it.
Talk your partner on it.
Partner.
Okay,
Looks like the angle stuff.
360 minus 280 is equal to 180.
Alright, so angle stuff. It's angle stuff.
1 by 30. So 30 plus 30. Or 30 times 60, 60. Okay.
Alright, that's 180, and then
That's 180, and then you do.
60, and then minus.
You're on the right track.
Oh, we got the pattern.
So it's only constant.
First is 180, and then top,
20,
and then
so blank first, so this one.
50. I'll be like, 80, 75.
7.5.
So I'll be 7.5. So minus that would be 63. Oh, 1 in UK.
I think there's more than just doing those. You really want to put space find the next one.
I'll do it.
do it you want. On the other side of the page.
What?
The next part is down.
Is there a relationship between 160 and 180?
Oh, gosh.
I'm gonna do it like super middle egg. Like the one. Yeah. But I went
Oh, 360 minus 180 was 180. Then 180 minus 120 plus 60. Then 120 minus 90 equals 30. And then 30 plus 30 is 60. 60 plus 60.
again.
Wait, no, 60 plus 60 does not equal 180. Equals 120. Darn it.
Oh, yeah.
I all I have is like the minus 60. I know. Minus 80, minus 60, but then goes to 30. So it's like.
Guys, here's the thing. Not all of them are going to be thinking about adding or subtracting. It's a great method. We've done that, a lot of them. Think about this not as addition or subtraction. Think about it as multiplication or division.
No way. Yeah, well, I have another way too. You could go like times 2, times 3, times 4, times 5. It's like,
No, that's a pattern.
that works though.
It does work.
Yes.
It does work.
I found another one. Yeah. Like, oh, times 3, times 4, times 6. 180 times 2, like 60 times 3, 30 times 4, 130 times 5.
Okay. So you're on the right track. But how do you do that from 360 to 180 instead of timesing it?
You said if I find another good I can say in your face. So
Divide, keep it separate.
yeah, I got it. Whatever. In
So like
his
this
it's
is half of that.
Oh, okay.
I should get one of those, like a shocking pen.
That would be so much fun. Here's your pen. Oh, yeah, yeah.
Okay,
Just
so who has an idea on this one? Raise your hand if you and your partner think you got it.
Yeah.
Okay. I won't call on this.
260 divided by 180 is 2,
Okay,
and then 360 divided by 120 is 3, and then 360 divided by 90 is 4.
so 1/2 of 360 is 180, right? That's what you're saying?
Yep.
And 1/3 of 360 is 120. 1/4 of 360 is 90. So then you're looking for 1/5 of 360. And 1/6 360. So what would your answer be?
I don't have a calculator.
Oh, I got it.
Okay.
First one is 75.
Okay.
The other one is 67.5.
Dang, honest.
1/6 of 360. Sure on that one?
Yeah, you should run that.
Yes, I'm sure.
I think it's 60.
Whatever. Oh, yeah, it is.
Isn't it 72 as well, Mr. Warren?
Yeah.
Your thing doesn't even work. You said this pattern was right.
Oh.
You had the pattern right. Okay.
And anyone else get 72 and 60?
Yep.
Oh yeah.
Okay. Now, I think Hannes had 65 or 75 and 67.5. And I think that also works. Let's talk that through for a second.
Dang, honest.
Oh, yeah.
Because if you think about dividing, it's 72 and 60. Now, the difference here is 180. The difference here is 60. The difference here is 30. So, but here's the question. What are we doing to this number?
Dividing it by 2.
180 divided by 2 isn't 60.
Oh, like times 2 and then like times 3 and then times 4.
So you're dividing this by 3 and
No,
dividing
like to get 360, you multiply it by 2. 180 times 2.
180 times 2. So you're dividing. 360 divided by 2 is 180.
Well, yeah.
So I'm just talking through because I thought this could work, but now I'm starting to doubt it.
Then my be 15, and then
Because this is what Hannes had, and here's guys. I'm just checking because I think it might work, but now I'm starting to think.
I got 15 and then 7.5.
But here's my question. Okay. So Hannes had 15 here. Difference is 15, and then 7.5. What's the problem? What? He kept cutting in half, but the problem is this. That's not half. See it, Hannes? I agree that that's half, and then that's half, and that's half, but that's actually a third. So I don't like that. Awesome?
You go left to right from what you get between 360 and 180 and 120 and 90 is 180, 60, and 30. If you double 30, you get 60 if you triple. 60, you get 180 if you triple. Or quadruple, 180, you get 360.
Mr. Cole, that's not how I did. I like did times 2 and then times 3 and then times 4 and then 5.
So what'd you do, huh?
I did like 180 times 2 and then like 60 times 3 and then like 30 times 4. 15 times 5.
Talk to me later, because we're losing everybody else. I'll talk to you. I want to see if there's another way. Because I think there might be, but I'm not sure. Talk to me later. We're going to move on.
Anybody have any questions before we move on? So when we're proving things mathematically, the easiest way to disprove something is through a counterexample. English, what is a counterexample? Austin. Oh, okay. Okay. Counterexample. Here. Something that contradicts that. You're right. So a counterexample is that a specific case for which the conjecture is false.
For example, here's a statement. I'm going to say, hey, if you're in Mr. Cole's geometry class, you have brown hair.
Yeah, that's true.
Who's the counterexample of that?
Honest.
Morgan, Hannes,
Honest.
Courtney. Those guys prove that statement false. All right? Here's another statement. It says, hey, if you are a math teacher, you're really cool.
That's true.
I obviously would prove that right, but Mr. Juffer may not.
I thought you were going somewhere else with that.
Don't tell him I said that. Don't tell him I said that. You guys get the idea, though? It proves it wrong. Go ahead.
Yes. So here's your conjecture. The sum of two numbers is always more than the largest number. What would be a counterexample to disprove that? Go for it.
Like adding up two negative numbers.
Adding up two negative numbers. So, -3 and -2, right? Okay, so the sum of those, you add them together, you get a -5. Is -5 greater than -2?
No.
No. No. So, that's false. What's your counterexample? How about this bottom one here? The value of x squared is always greater than the value of x. You guys think that's true or false? False. True. False.
True.
Believes. It's false.
You did 0. 0 squared is 0, which is the same.
So 0, x is equal to 0, right?
Oh, wait, no.
And then x squared is equal to 0 squared, which is equal to 0. Is 0, speaking mathematically, is 0 greater than 0? No, it's equal. False. There's your counterexample. What's another number that would work for that? 1. 1 squared is 1. 1 is not greater than 1. Yeah. Yep. Okay, so get out the other side. Does anyone have any questions before we move on, though?
Guys, who we use counterexamples when we start getting into math, and we'll do it all year round, and saying, hey, it looks to be true, something looks to be true, but does it have to be? What would be a counterexample of something? You have to think like, hey, what's going to prove that wrong? And we use that the rest of the year.
we did this on the last one. So unless I'm not writing. Review, right, Mr.
Yep.
Cole?
And then all the way almost on the right, start 18. There we go.
Okay. We did this on the last one, unless you guys wanted to go over it again. So what we're doing is postulates. Get out your notes from chapter 1. Remember what a postulate is.
Everybody got their notes. Everybody try to find postulate in our chapter 1 book. There somewhere. Under you.
He just looked like he has the answer. Okay, Courtney, what's a postulate?
A rule in geometry that is accepted without proof.
A rule in geometry that is accepted without proof. Exactly right. So what we use postulates as is like your common knowledge stuff, your basic stuff that we need to prove other things. Okay? So this one, there are any 2 points that exist exactly one line. What's wrong with this? Why can't there be 2 lines through there? Awesome. They're shaped. They're like that, right? Yeah. Lines are straight, exactly. So if you have a straight line through these 2 points, it'll go like that. If you think of another straight line that goes through these 2 points, it's that same line. So instead of saying there's a whole bunch of lines that go through those 2 points, there's only one line because they're all the same line. Does that make sense?
Yeah.
Okay. Rewording that, a line contains at least 2 points. Okay. No. Yes. The intersections of 2 lines is a point. So if 2 lines intersected in a line, what would they be? Yeah, that's what that basically is, that there's an intersection point. What I'm saying is, if you have 2 lines, right, like this, and they intersect in a line, it's just the same line again, right? So all that says is that for lines to intersect, it has to meet exactly in the middle at this one point. Do you have any questions on that? No. Awesome. Through any 7, it's not right. Through any 3 non-linear points, there's exactly 1 plane. So, what's non-linear mean? They're not all in the same line, exactly. So if I have a point here, a point here, and a point there, you can't draw a line of those 3, right? Unless it's curved, which we just talked about can't happen. So you have these 3 points. You can't draw a line, but those 3 points are all on this board, right? Which is a plane. Now, if I had a board that went like this, could I hit all 3 of them? No, exactly. So that's why 3 non-linear points, there's only 1 plane through that. So So 2 points, lie in a plane, then the line containing them also lies in the plane. This line is on the plane of the whiteboard, right? So are these 2 points? Does that make sense?
Yep.
Okay. The intersection of 2 planes.
Is there where you wrote this line?
What? Yes, that says line. Thank you. Okay, so the intersection of 2 planes. Name 2 planes in this room. Name the other one. Right. Where do those meet? There. What is that?
Line.
A line. Exactly. The intersection of 2 planes is a line. It's the same if they're going through each other like this. See how there's a line right there? Yeah. Okay. Anybody have any questions before we go on? No. Nope.
Yeah, no.
Maybe. Maybe not. Okay, sketching a diagram. So, you want to sketch a diagram showing TB intersecting PQ at point W, so that TW is congruent to WV. That's a lot of math. Let's break it down. What's TB?
A line.
A line. Thank you. You know it's a line because it has a double arrow above it, right?
Uh-huh.
So we have a line.
Got it.
T, B. What's PQ?
A line segment.
A line segment. How can you tell it's a line segment? Because it doesn't have the arrows. P, got Q. And they intersect, going back to our, I think it's our third postulate. The intersection of 2 lines is a point. We have a point right there. They tell us to name it W. Okay. So now we need TW to be congruent to WV.
What am I doing right at this?
Caitlin, draw a little tick mark. Like that?
Like a rolling dash.
Right. That was a terrible drawing of a tick, by the way. Okay. So everybody see that? What you're saying here. Okay. So at this point, you have TB, which is a line, and it's being intersected by PQ, which is a segment. And then it says so that TW is congruent to WV. We have tick marks here to show that those are congruent segments. Okay, you got questions?
No, we know.
Okay.
Your hand counts as a marker, you need to use it.
What?
Your hand keeps counting as a marker, that's why you keep missing the line.
Ah, thank you. Okay, who wants to do this one?
I'll do it.
Okay, first let's talk to our partner about what we should draw. Sketch a diagram between the 2 of you.
Okay, well, here we go.
WX is array, or VX is array.
No, nobody.
You know what?
I didn't know.
Use
So that V
He's not one.
Nice. Nice rag.
That is a rare.
I know, it's a nice rag.
Yeah, it's perpendicular. Perpendicular means like,
Like your nose.
yes, that makes that, to do that. And if you,
Who wants to come up and draw this for the class? You can't, you have broken wing.
what does that mean? On the same, you,
That's just that. That's just.
It's discrimination.
Yeah, great. No.
Yeah, my God.
Thanks. I'm always fine. My drawing has feelings. Same.
Perfect. Thank you. Who agrees with Brayton?
I agree.
I'll put dots for X, U, H, W.
Okay. Who doesn't agree with Brayton? Good, because Brayton's exactly right. You have Vx, which is a ray, intersecting UW, which is a line, at V. So that Vx is perpendicular. Here's our sign for perpendicular. UV and W are collinear. We're good.
You know what?
Last little bit here. We need to pick out which statements A through E are not true. So looking at this diagram. Okay. So looking at this diagram. Our first one's points A, B, and F are collinear.
Yes,
Yes. Why yes?
because of the second part.
Line that goes like that, right? A, B, F. So that is true. How about points E, B, and D are collinear?
Nah.
False. Why is it false?
And on the same line.
Because they're not on the same line. Exactly. Could you potentially draw a line through them? Possibly. But in this figure, it's not. So you're just looking at the figure. Because I heard some people say, okay, AB is perpendicular to plane S. True or false?
True.
True.
Because there's a right angle
Yes, there's a right angle sign. Who agrees with Hans?
That is.
Okay. CD, line CD, is perpendicular to plane T.
False.
Alex, what do you think? False. I like your answer. Why do you think it's false?
Not directly across from.
So CD is perpendicular to plane T. How did we know that AB was perpendicular? There's the mark, right? So, since there's no mark over here, we can't assume it. Okay. How about E? We think that's true or false? True. False. True. True. Why is it true, Chip? True. Okay. Agree? All correct. Do I pause? Stop. Mr. Cole?
You well done?
Yeah.
Pause it.